Good morning, guys. Today we're going to be talking about density. This is 10.4, week 5, day 1. What we're going to be working on is I can use mass, volume, and density to determine the population density of areas. So we'll be talking about density in the scientific way that you guys have probably talked about already this year. But we're also going to be talking about population density here. And population density is an extremely important statistic for us to know about and be able to calculate at any time. So let's go ahead and get started. Alright, so first we know density is the mass of an object per unit of volume. So very simply put, density is equal to mass over volume. If you guys remember this formula, you'll be good to go. A couple things with it. I can go ahead and I can solve for any of these variables here, density, mass, or volume. So density will be D for us, mass will be M, volume will be V. Now if we look at this, if I want to solve for mass, I'd multiply both sides by volume so that the volumes cancel out. What I do to one side, I must do to the other. So you get mass is equal to volume times density, as we can see right here. Further, if I wanted to solve for volume, then I would take our equation that we just solved for. Mass is equal to volume times density. And if I wanted to solve for volume, I'd just divide density by both sides. Divide both sides by D. And that will have the densities cancel out, and we'll be left with volume is equal to mass over density, which is the other equation that we can use. So those are the three equations that we need to know. Granted, if you know one of them, you know all of them. An easy way to remember this is just this triangle here. It says DMV. I like to think of it as, and this is an easy way to remember, mountain point is over desert vista. If you remember that, you're good to go. Alright, so let's go ahead and try some of these out. Example, you have two types of wood and want to see which one is denser. You have two logs with the following diameters and heights. So we have two different types of trees. We have a Douglas fir and a redwood. The Douglas fir has a diameter of 6 centimeters long. So if I were to draw the diameter of the Douglas fir, it'd be 6 centimeters. Meanwhile, the redwood is a little bit larger with a diameter of 8 centimeters. Now, the height of both of these is different. The height of the Douglas fir is 17. Meanwhile, the height of the redwood is a little bit shorter at 12. So, we also know their mass. That'll be useful when we get to step 2. But step 1, we just need to find the volume. So let's go ahead and do that. We use volume is equal to pi r squared times height. And I know diameter is equal to our radius times 2. So if my diameter is 6, my radius is 3. If my diameter is 8, my radius is 4. So we can automatically solve for radius right away if we have diameter. From here, we go ahead and we plug it into our volume formula. Volume is equal to pi r squared times height. It's the volume of a cylinder because trees will become cylinders, or at least logs will. So we go ahead and we use that to solve for our volume of the Douglas fir first. We use pi times radius squared, our radius is 3, times the height, 17. That'll give us 153 pi centimeters cubed. Meanwhile, for the redwood, I plug in 4 for r and 12 for height. We have pi times 4 squared times 12, which will give us 192 pi centimeters cubed. So just looking from this, I can see that the redwood has a little bit more volume than the Douglas fir itself. So one is a little bit larger of a piece of wood. Next, to find out the density, we're going to go ahead and draw our triangle up real quick, DMV. So we have our triangle, and we're trying to solve for density. So we know density is equal to mass over volume. So let's go ahead and use that formula right now. For our first one, we know our mass is 254 for the Douglas fir. And we divide that by our volume, 153 pi. And again, this is in grams. This is centimeters cubed. So it gives us 0.53 grams per centimeters cubed when we divide those two numbers. Now, I put parentheses on the calculator when I did this bottom one to make sure that it multiplied 153 by pi first. So make sure that you put parentheses on your calculator for these. Next, if we try it out for the redwood, D is equal to M over V once again. This time our mass is 271 grams. Again, we got that from our chart right up here. And our volume is 192 pi centimeters cubed. Again, that's from just our volume that we found a minute ago. If we do that math, we go ahead and we find out that the Douglas fir is 0.45 grams per centimeters cubed. So we're looking for which one is more dense, and that would actually be the Douglas fir is more dense because it has a higher density, a higher amount of grams per centimeters cubed in it. All right, this is the last thing that we'll be covering today, population density. We can calculate the population density of humans, animals, and other things. This statistic shows the number of people in a given area, usually a city, country, county, or state. So, extremely useful to know how many people are congested in a single area right now. And that's actually really useful in things such as what we're going through right now, is knowing how many people are in an area and the infection rate of that. So population density does have some significant importance to us, just knowing where people are at, where people are clustered, where they gather, and how many people are actually there. So let's go ahead and try one of these out. We know Arizona has 7.3 million people in it, and it has 114,000 miles squared for the area. We want to know the population density of Arizona. Well, to do that, we're going to go ahead and take our population density, I'll call it PD for now, is equal to our population, 7.3 million. Well, that's 7,300,000, and that's people, divided by 114,000 miles squared. Now, if we do that on the calculator, we end up with 64.0 people per square mile. That means that in Arizona, if you're in one of the blocks on your street, there's 64 people per square mile, typically. Now, granted, it changes where you're at in Arizona. If you're in the city, it's a lot different than if you're out in, say, Sedona or Williams or somewhere smaller in Arizona that doesn't have as many people living there. It's going to be a lot less population dense as well. So let's go ahead and compare that to Phoenix's population, which is 1.6 million people in 517 square miles. So again, same type of thing. Our population density is equal to 1.6 million, so 1,600,000, divided by 517. And of course, I want to put my units here. When we do this on the calculator, we end up with 3,094 people per square mile just in Phoenix. So that's a lot of people just in the Phoenix area in that small amount. So in Phoenix, 3,094 people. In Arizona in general, 64 people. And the reason that changes, again, is because in more rural areas, there's less people living there, which means that it's more spread out, more space per person, and you don't have that clustering of people gathering. So it changes based upon where you're at in the state. All right, so that's all I have for you guys today. I'm going to put an additional video for additional help for you guys at the end of this. So it's going to be in the end screen. It's going to link for you guys. So just keep that in mind if you want to use it. Practice is posted on Schoology for this topic. Make sure that you try it out. And then the assessment and the practice is due Sunday, 11:59. Thank you guys for watching. If you guys need anything, please let me know. Other than that, I'll talk to you soon. Take care.